Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazwan. Today our group we will present about our final report. The title our report is a heat sink. Okay, for my part I will explain about project background. A heat sink is a device that transfers thermal energy from a hotter device to a cooler fluid medium. Air is the most common fluid medium, but it can also be water, refrigerant, or oil. The heat sink is commonly referred to as a cold plate when the fluid medium is water. A heat sink is a heat reservoir in thermodynamic that can absorb any amount of heat without significantly changing temperature. To transfer heat via convection, radiation, and conduction, practical heat sink for electronic equipment must have a temperature greater than the surrounding environment because electronic power supply are not 100% efficient. Additional heat is produced which may be harmful to the device
Hello, my
function.
name is Muhammad Imraki bin Rohaizat, and right now I'm going to explain about the problem statements. Okay, the problem statement is a thermoelectric generator or TEG, also known as a Seebeck generator, is a solid state device that uses the Seebeck effect to transform heat flow directly into electrical energy. Thermoelectric generator works similarly to heat engines, except they are smaller and don't have any moving parts. However, the most difficult aspect of designing a thermoelectric generator is the load efficiency of the generator. Thermoelectric modules use the Seebeck effect, which necessitates a small temperature difference between the hot and cold panels. The thermoelectric module's efficiency improves if the temperature differential is maintained. To accomplish this, we'll need to create a new design of heat sink that functions as a heat exhauster and aids in controlling the temperature between the thermoelectric module's two sides. That's all from me. Thank you. We get two objectives from this project. Okay, the first one is to design the new pattern of heat sink for thermoelectric generator, and lastly to perform heat transfer simulation process of heat sink reducing temperature for thermoelectric generator. That's all for objective.
For our literature review, the source is from the Kumar Mishra, Kumar Singh and Ankur Prakash and Prof. R.S. Ambekar 2017. The title is Thermoelectric Generator and for the type of the article is International Research Journal of Engineering and Technology. Okay, for the major finding, the load resistance is variable in the equipment setup and the power generation efficiency of both load versus the voltage produced. The maximum temperature difference we tested is been 68 Celsius and it produced an output power of the 4.057 watt. For the conclusion of this source is this project determine the performance of the electric generator under mismatched conditions such as the limited working temperature and the inconsistent temperature distribution among the module in the series condition.
Methodology. Heat sinks are generally made of metal and aluminum is the most common metal used in heat sink. We are aware of the fact that the thermal conductivity of each metal is different. The thermal conductivity of metal is proportional to the heat transfer in heat sink. For the improvement, the plate, whether it must be in pinnet, finette, or surface, need to adjustment toward the height of the surface area and also the thickness as the distance from the heat sink base ground. The amount of heat transmitted by a fin to the coolant medium decrease. After complete the simulation, we notice that there are some weakness in our design, which is the area of the heatsink. We believe that if we increase the surface area of the heatsink, it will improve the performance of the heatsink, which is not the case because the heatsink performance not only determined by the surface but also by all the dimensional of the heatsink. If we increase the width of the heatsink. The heat dissipation capability also increase. Therefore, the priority should be to select a heatsink for the allowed wide maximum rate then maximum allowed fin height.
I would like to present about our discussion. As you can see, this is our heatsink after the simulation. After the simulation, you can see that temperature is affected with the material by referring the thermal conductivity. Thermal conductivity can be measured by the ability of the metal to conduct heat. After run the simulation, we noticed that there are some weakness in our design, which is the surface area of the heatsink, because the temperature at the cool side of our heatsink is not very different compared to the standard heatsink. The heat dissipation capability also increases if we increase the width of the heatsink. The important is to select the heatsink for the allowable maximum width rather than maximum allowable fin.
Conclusion: heatsink are essential part of the most electronic assembly, power electronic device and optoelectronic component. The specific heat exchange dissipate is generated by electronic device to ensure that they are operating within the limits specified by manufacturer. Some of the key factors that should be considered in heatsink design include a thermal resistance, material, field configuration, field size, shape, field efficient, heatsink, and attachment method, and the thermal interface material. Geometry and parameter that provide maximum heat dissipate was obtained by analyze different heatsink model. For the assignment, we need to do a design a heatsink simulation that specification was given for the assignment. We need to design the plate whether it must be a pin, fin and surface. Apart from that, we also need to adjustment toward the height of the surface area and also the thickness. After finish do the design, we must test it to see the result of the thermal analysis to achieve the correct specification.
That's all for us. Thank you.